So time to deal with zeros of polynomials. So zeros of polynomials, a polynomial, we know that basically it just makes curves. It can either be a line, can be something like this, several curves, just one, parabola. It's essentially, when we're talking about zeros, we're talking about where it crosses the x-axis. In the case of imaginary numbers, it's usually happens when we have a sum of squares, or somewhere down the line a sum of squares is going to occur where we're going to have two imaginary numbers that kind of cancel each other out when we multiply. But we'll get into that coming up. But for the most part, we're mainly going to be talking about x-intercepts, and the best way to find them, I personally think, is factoring and synthetic division. Long division, I feel, is good as well, but it involves a lot of writing for the same result that synthetic division would have. Remainder theorem, I mean, it works, but my personal favorites are factoring techniques and synthetic division. So let's get into this. All right, so finding the zeros. So we're trying to find the zeros for these solutions. So for example, see how there's 1, 2, 3, 4 curves. There's about 4 curves here. It's an even function. That's how you can tell there's 1, 2, and then the curves right here. So there's a few curves here, which means there should be about 4 solutions. But if you notice, it only crosses the x-axis twice. In case you guys were wondering what I meant by curves, I realized I was kind of vague on that. This going down, that's a curve. It stops right here. And then there's another curve here, but then it kind of gets taken over by a curve over here. And then finally another, let me do it here, another curve going this way. So there are 4 curves. However, there's only 2 x-intercepts, and that's why it talks about there's probably going to be some complex solutions there because there's curves. There's so many curves. Every x kind of creates its own little curve, so that's why I refer to them as curves. Now, the rational zero theorem, this is a theorem that will help you with your synthetic division. It's going to involve the leading coefficient, this one, and it's going to involve the constant. And the way you figure this out is essentially the idea of factors. So things that multiply to make your constant, your last number, without an x. Factors of your constant divided by factors. I should write that in a different color. Oh no. So factors of constant divided by factors of the leading coefficient. I'll just call it L leading coefficient. So we'll see what that is. This this shows us potential zeros. It doesn't show us all zeros, but anything that is a zero will be from that type of fraction. And notice here, you'll see this. So our p's are, and you have to account for positive and negative. So notice how we have a 1. And we also have a 1 for q. So this 1 is really important because it actually causes us to not have fractions. 1 divided by 1 is 1. 2 divided by 1 is 2, 3, 4, 5. So that's actually really helpful in making sure that we're not going to have those fractions. We have the 1, the 2, the 4, and the 8. And we will have some fractions, but obviously if you're controlling this, you're not going to want to try your fractions out. Odds are it might not even be an answer. It's very rare, I'm not saying it doesn't happen, where a 0 is going to be the fraction. You're going to want to try these numbers. So I usually try the 1 and the 1 first because it's the easiest one to do synthetic division with, and you can move your way along after that. So, and then it says we're going to try to solve it using synthetic division, which is what we've been talking about. So here we have all these numbers. So they're going to try a 1 first, like I said. They're actually trying -1 for, or no, they are trying the +1. They're trying the +1 first. They're like, oh, that didn't work. Oh, cool, a -2. -2 does work. And this is basically trial and error. It's kind of like the box method where we're going to try it out. If it doesn't work, move on to the next one. It's fine. Um, but one of the cool things that you can do after this is once you find one that works, you can continue on from that. So notice how when they're trying this +4, they're not going to go to the original one. They're like, well, we already found this. We're going to divide it into this new polynomial. This they call it the reduced polynomial from our previous video. So if you fail, cross that one off your list. Usually what I do is I cross out the sign that I tried. So I tried out a +1, and then I would try -1, and then I would try +2, because I'm not going to try the fraction. I'll leave the fractions till the very end. Definitely don't want to do those. All right, so moving on to the next one. Next slide, and they're going to keep doing it. So notice how there is a fraction. I did say sometimes there's not a fraction. This one, it looks like there is. So it's definitely something you can do. But what I usually do is I try solving this first until it's the very last option that I have to do. And like I said, you don't have to try all of them because this curve, if this has power 3, degree 3, that means there should only be 3 answers. So why they tried the negative version, I don't know. It's a little weird to me. Oh wait, 3. Yeah, it should only be 3 answers. So, well, let's get going. All right, and you can always use the quadratic formula, but usually you end this with the quadratic formula. So the first thing you're going to do when it comes to the remainder theorem is you're going to do P over Q, then you're going to use synthetic division, and then if it's too complicated to factor after all of that, you use a quad formula. I like using the quadratic formula as a last resort. If I can factor it, I'm going to factor it instead of having to plug in this formula. Some people just prefer like, hey, I already did all this work trying to prove it with synthetic division. I'm going to use a quadratic formula. And that's another reason why I usually don't like plugging the fractions. It's like I'm going to get rid of all of my integers, all of my whole numbers first. And if there's a fraction, it'll probably show up when I'm doing the quadratic formula. All right, so let's get into this. All right, I was like, where are the actual problems? I'm like, we're making 3 videos because I was expecting this to take a while. So, first things first. The first question is asking me, what are possible, um, what are possible, whatchamacallit, blah. What are possible zeros, potential zeros here? So what I'm gonna do is I'm actually gonna make a table to solve this. So I'm going to insert a table. We need a P, we need a Q, and then we need P over Q. And then we're going to do two. So this, you can always insert a table to help out. Luckily, it's going to make it even. So you can always make this bigger and it evenly distributes the roots and the columns. I actually don't really need it to be this even, but I guess that works out. I don't know if there's a way to make it smaller, but okay, so P, or I should say factors. Factors of P. And remember, P is our constant. I say remember because I honestly forget a lot of times. Factors of Q. I always have to look it up when I'm doing this. Factor of Q, leading coefficient. All right, and then finally we're gonna have Unfortunately, can't really do fractions without doing this. We're gonna have p divided by q. Knowing the formula to me is easy. P over q. It's in alphabetical order. P then q. Um, it's just, oh, what happened here? I'm using, oh, this looks terrible. What happened? I don't know what happened here. There's something invisible. Oh, no idea how I did that. I'm not a fan of it. I think it just might make it smaller based on the fact I was typing there. So I'm looking for factors of 15. So obviously there is, well, let me insert the formula. We're going to use the plus or minus formula. So factors of 15, let me use my pen here to kind of draw this out. So things that make 15, 1 times 15, obviously. Nothing with 2, 3 times 5, 4, nothing, and then we would get to 5. So what I was kind of doing was going this way down the number line, and then this way up the number line. So 1 times 15, 2 doesn't work, 3 works, 4 does not work, but then I would have to see that, oh, after 4 is 5. So things that I see right off the bat, integer-wise, are this. You're not going to want to type in fractions here. Um, the whole reason of this theorem is so you just account for the integers, and the fractions will show up when you do the p over q. All right, so I said 1, comma, I'm going to copy this plus or minus sign so I don't have to keep looking for it every time I want it. 1, comma, plus or minus 3. Oh my gosh, what happened there? What are we doing here? Control V. Okay, there we go. I don't know why I deleted it the last time. And then we're also going to do Control V. 5. What are you doing, Edmentum? Why are you like this? I don't know why it keeps erasing it the first time. That is weird. All right. All right. So those are our factors of P. So now we're going to want to do factors of Q. So me being lazy, I'm going to copy this, paste this here, and then we're going to go into it. So highlight it, do your equation editor, and we're doing factors of 4. Well, factors of 4 are easy. We have 1 and 4. And we also have 2 times 2, so plus or minus 2. And because we're already up that number line again, we can just leave it at that. So there's 3 potential factors here. So the first one I'm going to do when I do P over Q is I'm going to want to get rid of that 1 first. I want all of my whole number first. That way I don't have to worry about those whole numbers later. So what I'm going to do here is I'm going to do this. I'm going to leave a space here so I don't have to deal with that erasing thing. I don't know what that was about. So 1 over 1 is 1. 3 over 1 is 3. So basically, wow, Edmentum, what is your deal? 3 over, so we're doing all of P. So obviously when you're doing P over Q, all of the P's are valid answers. So those are the ones I usually start off with, is all the ones that are the P's. It just makes things easier. You'll see also that it's not just the P's. You'll have other candidates for potential answers. And I'll show you what that means in a bit. It doesn't look like it works with this, but let's pretend that one of the factors of our Q was a 3. Well, 15 divided by 15 would be 5. So stuff like that can happen. Doesn't look like it's happening here, but um, it can happen. Um, let's see what we got here. And we're going to want to keep going. And unfortunately, now we kind of got to the point where we need not only this, but we need the fraction button. And me being lazy, I'm just literally going to copy this down and write something. All right, so now we're going to want to do, I'm going to do the 2. So 1/2. And I'm just going down the list here. So the next one would be 3/2. So I'm doing the 2. Now, luckily, you don't want that many factors of q, but unfortunately, we can't control that. So this one's nice because it only has 3 factors. So we only need to do 3 sets for every p, which, like I said, could be worse. So we're doing 5/2, comma. I just realized I should just, oh, I know what to do. I'm going to do this, and I'm going to add a comma here too. That way I can just erase the comma of the last one. Next one is 15/2. And now we're going to do the 4th. So 1/4, 3/4, 5/4, and last but not least, 15/4. And because of how long this is, I'm sure the box is also going to change once we do this. Yep, it does adjust based on how many you're doing. So these are all the potential ones we have. They have it. Oh, they have it in the same order. Well, ish. I don't know why they decided to go. Oh, we're gonna do all the p's, then 1 over everything. Then so they did it a little differently, but same ideas there. All right. So now we're gonna test out a number. So obviously, I want something where when I bring this 2 down, it's going to multiply and give me a -2. So 2 times what gives me -2? Well, that must be negative 1. Sorry, I don't know why I put a -2. I was just thinking I want this -2. So 2 times -1 will give me that -2. Bring it down, gives you -1. -1 times -1 is +1. So 4th. So I already tried -1. I don't understand this exercise because it's like you already did this. All I need to see is like 2 times what gives me 1. And that's going to be 1/2. So 1/2 hopefully allows me to do that. I'm a little worried about that right now because I don't know if they're going to accept it this way. Now our zeros are so we want to find the zeros for this. So the easiest way to find the zeros for our remaining polynomial, this right here, is 2x squared minus, minus 18 equals 0. So this is 2x squared equals 18. So x squared equals 9, and the square root of 9 is not only +3, but don't forget to account for -3, because -3 squared is also 9. So we're going to account here for 3 as well as -3. I'm going to assume it's saying I'm wrong because of the fact that you can call this a 0.5, and that these two are supposed to be in smallest to largest. So let me read this. Enter least to large. So that's one of the reasons why I got that wrong, is I didn't read directions. It says fraction bar, so that has to be 1/2. 2 times 1/2 is 1. That's weird. I don't understand why I got that one wrong. If necessary, use the dash as a fraction bar. All right, let's try this again. So the first one we said was -1. That one was fine. The next one was 1 divided by 2, least to greatest, and we wanted this to be -3, and we want it to be +3. So I don't understand why they're saying that half is wrong. Still don't understand it. Just goes to show you that Edmentum follows its own rules sometimes. Unfortunately, that just kind of happens. All right, so let me refresh this page because I don't know what is going on right now. Luckily, I paused the recording for that. It ended up sending me back to slide 1, but let's get this finished. Find all zeros for this. So when I'm doing this, this is a 1. Luckily, our Q is a 1, so oh, that makes it so much easier. So we're only looking for factors of 29. Well, we're lucky. 29 is a prime number. So the only options we have are plus or minus 29. And let's kind of get this started. So I believe, how have they been doing it? It's kind of like this. The 1, -5, 33, and 29. -29. All right, so first things first, I'm going to try 1. Is that an option? Because it's plus or minus 29, but 1 is always an option. And I'm willing to bet it's going to be 1 because guess what? There's a 1 here. So we not only have plus or minus 29, I forgot to mention that because of that we have plus or minus 1. Considering that +1 is an option, and we can't divide 29 by 2, and we can't divide 29 by, what's the other option? 3, I'm pretty sure we're good. And we're going to be left with complex numbers at the end, but we'll deal with that when we get to it. So we're going to do a 1 here. We're bringing down the 1. 1 times 1 is 1, so that's -4. This is -4, which ends up being -20 or +29, derp, which is +29, which makes this 0. So now we have x squared minus 4x plus 29. So this is where I mentioned that you might as well go into solving this with a quadratic formula. So we're going to do -b plus or minus b squared all over 2a. By the way, that's not the whole formula. I rushed it, obviously. -b plus or minus the square root of b squared. I'm just going to square it right now. 16 minus 4 times 1, which I'm not going to write down because it's not really necessary in this case, because 1's the a. C all over 2a, which I'm just going to write down as 2. This is going to give me 4 plus or minus the square root of, let's see, 25 times 4 is 100. So I'm going to say 116. What I did there was kind of think about this easier. I was like, 4 times 29 is the same thing as 4 times 25 plus 4 times 4. All over 2. And this is going to end up being 4 plus or minus the square root of -100 all over 2, which ends up being 4 plus or minus 100. 10i, because the square root of 10 is I, or square root of 100 is 10, and square root of -1 is I. Divide this by 2, so we're going to divide the 4 by 2, and we're going to get 4, or 4 divided by 2 is 2, and it's going to be plus or minus 10 divided by 2 is 5, so it's 2 plus 5i, and then we're going to get 2 minus I. So this is what I meant by we're going to end up getting numbers that help cancel each other out. So this doesn't look like it would have an imaginary number, but guess what? If we multiply by the conjugate, it does. So this is one of our other options. And then let's not forget the one that started this whole mess. And self-evaluation, I would say I would give myself a 3. It is hard to understand what Edmentum Edmentum wants as an input. And that's more along the lines of like Edmentum just not getting it. Obviously, it put the right answer, but it disagreed. All right, so let me go on to the next problem, or the next page, I should say. So now we're going to be dealing with graphing zeros. Well, this is really easy. You just click where it is. You can do it with a graphing calculator. However, it is a little challenging because you have to do this approximate zero where you click a little bit to the left of the zero that you want and a little bit to the right of zero. The reason why is just in case you want a specific zero. Like if, for example, if this was a profit chart, you're like, I want to see where I break even within the first 2 months, or where I break even after 6 months, or if at any point before I started keeping track, negative time as it were, did I break even? So the graphic calculator want to do that. Desmos is a little nicer. You can click it or click. What I do is click and move my mouse, and it'll kind of like and wait until you get that zero for the y value, and that'll help you out there. Um, what's going on here, guys? No, what's going on with my page 43? Let's go to 44. Okay, there we go. So again, more zeros. One thing that they will cover is this thing called multiplicity. Um, I don't know if they cover that here, but the idea of multiplicity is usually it's multiplicity 1, meaning it goes just straight through. Then there's a thing called multiplicity 2, meaning that it bounces. And the reason why this is 2 is it's this right here, whatever this is a 0 for the curve going down, and it's also a 0 for the curve going up. Then there's another multiplicity. I haven't seen it go higher than 4, but I mean, they can. Once you get higher than 2, it's where it goes straight through. And this one, I still honestly have trouble understanding why it's multiplicity 3, but I know it's basically multiplicity of an odd number higher than 2. Similarly, this can be multiplicity of an even number higher than 1. So these bounces, we just know it's a multiplicity of an even number. This one's of an odd number. But most of the time it's going to be like, oh, it's a bounce. That's multiplicity 2. Like I said, you might not have to deal with. The only reason why I say multiplicity is like, let's say we do have that bounce. Let's say we have that bounce right at 2. Like this is the x value 2. That means that it's going to be something like x minus 2 squared. It's bouncing right there. All right, so moving on. As always, watch these on your own. I think they're very useful. It'll also explain possible values um, of zeros, and I think that's going to help you out a lot. All right, so moving on, and I'll work through a problem with you even more if you didn't understand me. So far, we've learned about real numbers, complex numbers, and stuff. So eventually in calculus, you'll actually know how to do it when we're doing about rate of change and stuff, but worry about that later. So right now, we're going to do another activity on how to graph this when we know the zeros. All right, so zeros in the polynomial. So this one, oh look, multiplicity 2. This little squared means we're going to have a bounce. Now, the easiest way to determine how your graph is going to look is to first realize, is it positive or negative? Well, actually, the first thing you want to do is it even or odd? So first thing you want to do is ask yourself, Is it an even degree or an odd degree? And the way you do that is by adding up all the powers. So here's 2. This is invisible 1. This is invisible 1. So this graph is even. Now that you figured out that it's even, you know it's gonna look like a parabola basically. Now you need to know if it's positive or negative. If it's positive, um, I like to think of it as like a happy face. If it's negative, think about it as a sad face. Um, so this is, since we don't have any coefficient here, I don't know if you can see that. Let me use my big old eraser here. Since there's no coefficient, no negative sign here, that means it is a positive. So we're going to do this little happy face here. All right, so let me erase all of this. So you know that the end behaviors are going to be somewhat like this. You just need to figure out everything that's happening in the middle. So let's figure that out. So first things first, we want to graph all of the zeros. So when we graph all of the zeros, we're going to look here and we're going to select a point. And this is a -1, so x minus 1 equals 0. So in other words, we want to point at 1. Next, we're going to want to point at -3. So for all of these, we're going to do x minus 1 equals 0. We're going to have another one that's x plus 3 equals 0. And we're going to have another one, x minus 2 equals 0. So our answers are going to be that +1, this -3, and a +2. And we can submit that in. So there's all of our zeros. Perfect. Now this next one, determine the zeros of the polynomial of this. Okay, so apparently I got into way too complicated stuff with that first lecture for these problems that they're giving us right now. But we'll get into what I said later. So if I do this, first thing I want to do is I'm going to want to factor out an x. So I'm just going to type in my work here just to make it a little easier for you guys to see. So I'm going to factor out an x. So the first one's going to be x squared minus 2x minus, wait, what's going on? Ah, there are 2 x's here, 2x squareds there. So give me a second to account for that. It's not minus 2x because these two combine to make -6. I thought there was way too many terms. So that's a -6x plus 8. I was like, wait, how is it a cube, but there's 4 terms? There should only be, you're not 4. 1, 2, 3, 4. 4 terms, but no constant. So it would have been 5 terms, considering there should be a +0 here. So we get that. Now from here, we can actually factor it a little bit more by assuming by using the x rule. So if we do x, they need to add up to -6, but multiply to +8. So in other words, -2 times -4. If we add these two together, we get -6, but if we multiply them, we get -8. So this will end up factoring into x minus 2, x minus 4, and all of this is equal to 0, so we get x equals 0, as well as, I'm going to do this thing right here, 0, and we have a 2, and we also have a +4. So remember, it's going to be the opposite of whatever that is. So those are our answers right there. Okay, submit it, and you can see they did the exact same thing. Oh, they didn't do the exact same thing I did. They got way more complicated. They're like, we're going to factor by grouping instead of using the nice x method. So whichever method works for you, but I personally think it's just better to use the x method or the box method. All right, so now we're going to draw, what does it want us to do? Draw the zeros from part A. So use the drawing tools. From the correct form, graph the zeros obtained in part A. Oh, this part. Okay, I was like, what? All right, so we're just going to graph the point. So do the point. We're going to graph 0, 2, and 4. So 0, 2, and 4. Submit that. It's cool. Go into the next one. So now they want us to do a rough graph of this. So a rough graph of this, we're going to want to use this little like curly thing. But this is where I was talking about we need to count all the things. So if we count here, we have 1, 2, 3, 4, 0, 4. So it's degree 4. Because we're counting all these terms, all these invisible ones. And it is positive. So we know it's going to be like a smiley face. It's a parabola, basically. It's not an S. Those are your two options. It's either an S for odd or a parabola for even. So just think of it as even, two sides, odd, 1, 2, 3 curves. So when we're drawing this, we're going to want to grab, I'm assuming this, and they already graphed our zeros, so they were nice enough to do that. So we know it's going to end coming, so it's coming from up here, and it should go through each dot once. So I guess they don't want that. I don't know what, oh, you know what? For some reason, as a teacher, they don't let me draw on here. So I'm not going to be able to actually submit it for you guys. Yeah, they're not going to let me draw. So I'll show you what it's supposed to look like, and then I'll just hit the submit button, and I'll just give you the answer. So what's going to happen is we're coming from down here, then we have to go back up through here, then we have to go back down through here, then we have to go back up, oops, up through there. And they should be touching. I just really badly drew this. So that's what I mean by it's kind of like a smiley face. There's still curves in the middle. I mean, there's going to be curves. But that's a rough drawing of what should be happening. And then you can see it right here. It's kind of like this W. And it can go down lower, it can go down higher. So again, guys, always review how you felt you did. Really go in there, and if you're having trouble understanding the end behaviors, where to begin drawing the graphs and where it should end drawing the graph, write it down. If you're having trouble using a factoring, write that down as well. But yeah, this one for the most part was pretty simple. We didn't really have to go into the rational theorem or anything. So that was nice. All right, guys, and summary. So as always, watch the video so you can get a good idea of what you learned. It's gonna help you for the test. That's just what this comes down to. And well, we'll see you guys next week. Hopefully, the next videos aren't gonna be as demanding, where I have to break it up into 3 parts. But have a good weekend, guys.